Bats are mammals, just like you and I. They're endotherms, meaning that they're warm-blooded, so that they also have hair, fur, mammary glands. They're vertebrates, which means they have a backbone. They breathe with their lungs, and they also give live birth. So bats are relatively unique in a couple of different ways. And the most unique way that bats that bats are is that they are the only mammal that can truly take flight. Their wings are thin membranes of skin that are stretched taut over top of their elongated finger bones, and they use that to flap and catch air. So, you know, we also have other mammal species that people refer to as some like flying squirrels and stuff, but they're not actually capable of true flight. They're more gliders. Bats are actually able to generate thrust from a standstill point and continue to have continued flight if they want to throughout different like from point A to point B. So they're able to sustain that thrust and maintain that flight capability as long as um, their existing internal energy commitments allow for. So anatomy is relatively the same among all different bat species that we'll be seeing in the Northeastern Ohio area. And so I mentioned, bats have are mammals, and so that their wings are also kind of similar to humans, as you can see in the bottom, the right corner of the slide there. There's a comparative view of humans and bats. So all of their finger bones, they are articulated, and they're able to maneuver them, and that way they're able to manipulate their flight patterns in order to keep up with their prey or any type of object avoidance that they need to. Um, and as you can see, they have the same similar upper arm, lower arm, wrist configuration, metacarpals, and fingers as what we do. Theirs are just extremely elongated compared to ours. Um, Other typical bat anatomy that it's good to know, especially when you're surveying for bats and trying to use them for species ID, is the ears, forearms, tails, foot, and like I mentioned earlier, the anatomy is relatively similar within um, all the different species. The species will have different variations in lengths and shapes, and sometimes the tail membrane is absent in some of the species that are more western, down in Texas way. Um, Now, for telling the sexes apart from the bat, as you can see from the picture on the left, it's pretty standard with most mammal species. So the bat on the left-hand side of that photo is actually a male, and the bat on the right side is actually a female. So it's pretty. So when we're IDing bats to sex, we're also looking at these in order to determine if the population is healthy with males, females, stuff, situations like that. Another, I guess, specialization that bats possess is um, their capabilities of echolocating. So I guess I'll step back for a second. Though bats actually have really good vision, despite that their small eye size, and there's actually been studies that have shown that bats can see just as well as you and I can. Now, that being said, they have developed they have evolved into using echolocation primarily because of the environment in which the feed and hunt at. So bats are in the Northeast in Ohio, they are insectivorous, meaning that they will eat only insects. So most of the insects that they are eating are out at nighttime. So regardless if they can see really well or not, like you and I, we still have trouble seeing at nighttime. So this kind of gives them an advantage to helping them to be successful to catch their prey. So echolocation is defined as pretty much the location of objects by reflected sound. And so how bats echolocate is they emit high-pitched frequencies in which we refer to as ultrasonic frequencies that bounce off the surrounding environments and back to the bat. So like I mentioned, it's an important tool in locating prey as well as object avoidance. So when bats echolocate, they send out high-pitched frequencies that bounce off the object and return back. back to the bat's ears and how they're able, and it pretty much allows them to see sounds. In most of their echolocation calls, they're above the standard um, hearing range as what most humans can hear. So most bat echolocation calls exceed 18 kilohertz in frequency, where that is pretty much the top of the limit of what most humans can hear. Now, bats, in addition to their echolocation, they have also adapted these large sensitive ears that help to collect these echolocation sounds back and allow for their brain to process it so they can see what's out in front of it. The echolocation allows the bats to recognize not only the size and shape of an object or animal, but also the texture and determine if it's moving or not. So when bats are feeding in the evenings, they can eat anywhere from 25 to 100% of their body weight, and sometimes more if they have pups in the roost. So typical feeding or typical diets of bats, especially in the Northeast and Ohio, it's going to be entirely insectivorous, but various bat species throughout the southern United States as well as other countries, they will also eat fruits, flowers. Some species will eat fish, and some species will even eat frogs. So a little bit on bat behavior. Most bats prefer to hunt and fly during the evening hours or early morning hours. So we typically, and while bats are nocturnal, most people typically think the bats are out being active throughout the entirety of the night, and that's not necessarily true. So what bats typically do, they'll emerge at dusk. They'll go find something to eat. They'll go find something to drink or drink and then eat. And then they'll get their stomachs really, really full. And then they'll either take a rest, depending on how far they had to travel to their forage ground, or they'll go back to their roost if they're nursing any pups, and then they'll feed their young. So in kind of that system kind of progresses throughout the night. So they'll emerge, get their stomachs full, get a drink, come back, digest it, take a rest, go back out, eat a little bit more, get something to drink, rest, take a break, and then typically before the dawn hours, they'll go out and do the same thing before it's bedtime for them. They'll go out and get something to eat, get something to drink, and then return for their to the roost for the remainder of the day when they're resting. So most bats will fly anywhere from a couple 100 feet to 5 miles from their daytime roost to a feeding site. And typically, like I mentioned, if they're taking breaks, depending on the length to their foraging grounds, some will use temporary roost sites before returning to their main diurnal roost. So it's all dependent on not only the bat, but also the distance to their feeding ground, if they have those transient roosts or not. Bats are also fairly secluded from society, often keeping themselves. For their roost, they'll seek out dark, secluded spots such as like caves, mine portals, hollow trees, abandoned buildings, bridges, houses, stuff like that. Anywhere that they can feel not only safe, but also kind of somewhere that maintains the temperature and environment that they need to survive. So bats will also, when they're in their roost, they will roost in either singly, so by themselves in pairs, or in small groups, or in large congregates. And so typically, depending on if they're roosting singly or in large congregates, it depends on not only the species, but also the type of, or the sex of the bat. So a lot of the tree bats, which I'll get in here in a little bit here, they typically seem to roost either singly or pairs. They don't typically have the big congregations of colonies as what the cave hibernating bats do during the summer. So they will roost singly, as well as a lot of juvenile past year juvenile males will roost singly too, because they don't need the higher temperature requirements that the maternity colonies do. Now, maternity colonies, they during the summer, they'll typically have larger congregations of bat groups, and this is so that they can maintain the temperature requirements and without they can maintain the temperature, stable temperature requirements needed to help nurse and raise their young. And so the benefits of a larger colony is, so if there's more bats or animals in an area, it's each other is helping to maintain that constant temperature. So they're using less energy trying to maintain their internal body temperature in large congregates than they would be by themselves. So less energy spent with self-body regulation allows for more milk production in order so that they can they can more successfully raise their young. Now in winter, so bats are one of the true few hibernators of the mammalian order, so they have to deal with a deep cold and a lack of insects. So in Ohio, in the Northeast, typically 6 species of bats we will see that go into this hibernation process. And so they will typically, and this isn't like these dates aren't set, but they typically go into their hibernation cycle in and around September, and they will stay into it in and around March. Now, prior to the hibernation cycle, before they migrate to their hibernation caves or wherever they're hibernating for the winter, bats will go into from the summer roost into what they call kind of like a fall swarm period, and that's basically when bats get super hydrophagic, and they'll eat and consume as many insects as they can so that they can build up their fat reserves to sustain themselves throughout their hibernation cycle. And like I said, it's not I don't want to say not a science that they go into these activity periods at these exact dates that I am showing here in their life cycles, but this gives a rough estimate of the typical life cycle of a bat. So bats are active through most of the summer period, anywhere from middle of May throughout the beginning of September. So that's when they're actively foraging in the landscape. They're raising their young, and it's when they're being the most, I guess, the most active versus the non-active season. So that can be anywhere from the roost periods. There's some maternity colony formations when their young's born, when the young are becoming volant, the whole way through, like I just mentioned, when they're getting hyperphagic and going into fall migration into swarming. So most bats typically mate in late summer, early fall, while some species can also breed in winter. So bats, the species that we have up here, they have what we call delayed fertilization. So when the bats mate during the fall and late summer, the male's sperm is stored in the female's reproductive system until spring, until they wake up out of the hibernation cycle, and that's when fertilization occurs. So baby bats, what are referred to as pups, they're born altricial, and basically that means that they're born helpless and requiring significant parental care. In the PowerPoint slide, the photo at the bottom right, you can actually see a baby bat that was just born. And so you can see it's entirely hairless. Its eyes aren't even open yet. So therefore it's going to require, it's going to depend entirely on its mother until it's able to be self-sufficient. So typically, again, depending on the species, depending on the colonies, most pups are able to fly within 3 to 4 weeks of being born. But even after they're able to fly, they still rely heavily on the roost as well as their mother to help teach them how to forage and how to survive throughout the summer. Typically, bats will only also bear one offspring or one litter a year, and it's for most insectivorous bats. Now, there are some species that will sometimes produce twins, but that's only 1 or 2 species that we'll see up here in this section, up in the Northeast and also Ohio. So bats have very low reproductive rates as well. Like I said, they're only producing one pup each year, which is typically in and around June through middle of July. It all depends on when fertilization occurs. But however, even though they have low productive rates, they are relatively long-lived. And so depending on the species, they can live anywhere as long as ideal conditions are right, anywhere from 15 to 30 some years. And I believe so for the federally endangered Indiana bat, they have a record of that one bat being 41, 42 years old. So for as small as these animals are, that's pretty significant compared to other animals that are relative to their size. And so the top picture here on the screen to the right of the life cycle chart 2, this is actually a female bat giving birth to a pup. And so what they do is typically, we think of bats, they hang upside down. Well, when females are giving birth, everything is kind of upside down. It's not really ideal to give birth that way. So what they do is they create a cup with their wing membrane and tail membranes. And so the bat is actually able to come out securely within this little cup that they create by hanging by their hands and feet. So that way, once the pup emerges, they're able to latch onto their mother and begin nursing right away. And it also helps with these larger colonies. If there's several females giving birth at one time, they're bumping into each other. So it also helps prevent it also helps maintain security and prevents the bats from accidentally getting dislodged and falling to the floor or falling out of the roost. Because like I mentioned, since they're born hairless, unable to fly, and essentially blind, if they would fall, then unfortunately they would most times unlikely be able to make it back up into the roost with their mother. So as I mentioned, bats are one of the true hibernators. In the Northeast, I think the other species, there's only a few other species that are true hibernators, and that includes a groundhog, chipmunks, and 2 species of mice. And so for true hibernation to occur, so the body temperature needs to decrease to almost ambient temperatures. Your heart rate needs to slow down. Your respiration needs to slow down. And then certain physiological changes in the blood needs to occur so that all these processes kind of intermingle and work together. So they go into this hibernation cycle because their food sources are not available after the fall or into the fall and in the winter months. So the bats have to go into the hibernation cycle in order to offset this lack of food. So before hibernation, as I mentioned a few slides ago, bats go into this kind of like this hyperphagy where they're eating all kinds of insects in order to get fat, in order to store up these fat reserves so that they're able to sustain themselves through winter. And typically when bats go into hibernation, they go into what we refer as a hibernacula, hibernaculum, and that's basically just a fancy term for a location where bats reside for the winter to hibernate. A lot of the characteristics that bats are looking for in hibernation environments are stable temperatures that typically maintain around just above freezing, so 35 to 40 degrees Fahrenheit, and they need a steady airflow too, so that so that all of the environmental conditions are stable. That way they're not constantly changing, because if they're changing, then bats are going to have to wake up out of their hibernation cycle and readjust in order to kind of find a more ideal spot so that they're not using their stored energy at a faster pace than what they should be. So typically in the Northeast, a lot of these environments where we're seeing bats hibernate are caves, mines, old railroad tunnels, rocky outcrops, anywhere, like I mentioned, that there's a stable temperature environment that's keeping the bats out of the external weather conditions. So as you can see from these pictures, the middle left one looks like there's little bumps of, or not bumps, just like little blotches of black up on the ceiling. That's actually bats all clustered together there. Some of the blotches are bigger, some of them are just single bats. And then the top right photo shows a little zoomed in picture of what they look like all huddled together. So similarly, with the summer habitat, bats will either root or hibernate in pairs, or they'll also roost singly, like the tricolor bat there at the bottom. And that's it's somewhat dependent on the individual bat's preference, but then also sometimes it's dependent on the species preference. So a lot of your Myotis species tend to clump together because they tend to prefer colder environments. And like I said, when you're bunched together, it helps to self-regulate that little pocket and that you're hibernating in. So you don't have to worry about the temperature changing so much all around you. Now with the tricolor, they seem to prefer and be tolerant of a little bit more warmer temperatures. We typically see them roosting more singly because they're able to tolerate these higher variations in temperature. So during the active season, and even during the winter season, there's a variety of different habitats that species can occupy. But typically, if we're looking at the active season, when they're out on the landscape, we're looking for three essential components for them to be in an area. So we're looking for a prey load, which is a food source. We're looking for a water source, and then also a shelter. So Northeast bat species during the active season, they will use woodland habitat for feeding and or roosting at some point during the active season. Many of these species will feed along stream corridors and over water. Now, typical, I guess, if we're going to generalize active season summer habitat for a bat, it would include a wide variety of forested and or wooded habitats where they can roost, forage, and travel, and may also include adjacent and interspersed non-forested habitats such as like wetlands, ag fields, fence rows, and or pastures. Now, conversely, if we want to look at examples of what wouldn't be considered great habitat or unsuitable habitat for bats, it would be individual trees that are just solitary and maybe surrounded by large urban areas, even like clusters of little trees that are found in highly urban areas like street trees, downtown areas, or pure stands of trees that are less than 3 inches DBH. So something really thin that might not have cracks and fissures in it that they could squeeze into and roost into, so that areas that wouldn't provide that security that they look for within roosting sites. So the typical bats that we would see in the Northeast as well as Ohio, there's typically 9 species that regularly would visit, and they all belong to the family Vespertilionidae, which just means they're insectivorous, basically. So of these 9 species, 6 of them are cave hibernating bats, and 3 are tree roosting bats. So the cave hibernating bats, we'll see them during the active season, but then they'll also go to caves and mines around here, and they'll hibernate here during the winter. Where the tree roosting bats, while some males might stay up here, a lot of them, once the weather starts getting colder and the prey load starts to dwindle, they'll start moving down south to where the prey abundance is back to more, I guess, optimal ranges. So of all these 9 species, though, the size range can go anywhere from a 16.4-inch wingspan, which is a hoary bat, which is one of the migratory bats that'll migrate down, all the way down to the tricolor bat, which has a wingspan of about 8 inches, 9 inches, somewhere in there. So as you so with the PowerPoint slide here, you can see the silver-haired bat, the hoary bat, and the eastern red bat. Those are going to be our three primary tree bats that we'll see. So, like I said, they'll be here up in the northern areas of Canada throughout the active season. But once everything starts to cool down, they'll start migrating a little bit south. Now, the cave-dwelling bats that we see in these areas are going to be the small-footed bat, the tricolor bat, the big brown bat, which is probably the most common bat that we have in the landscape anymore, the northern long-eared bat, the Indiana bat, and the little brown bat. So like I mentioned, the three to nine that we will typically see in the Northeast are migratory tree bats. And so they are comprised of the silver-haired bat, the eastern red bat, and the hoary bat. All of these bats will forage high above the trees and along forest edges. And like I said, they will they will spend their summers here and farther north in Canada, but then during the winter, they will start to head down south, with exception to some males that may stay and try and hibernate, especially some of the males within the silver-haired some silver-haired bats. They have found actually some males hibernating in environments such as just wood piles that people have had stacked up. Now, one thing to note, the U.S. Fish and Wildlife, they are actually reviewing the hoary bat status, and it's just under discretionary review for federal listing. But that's just something, it's not required of them. It's just something as their review plans have come up that they're starting to look at more, and that's mainly because of all the solar, the wind turbines that are going up, because unfortunately a lot of where the ideal wind turbines are placed, it's within their migratory pathways for all of these bat species, specifically the hoary bat. And so again, these are our 6 cave hibernating bats that we typically see. They're small insectivorous. During the winter, they'll roost cave mines, abandoned tunnels, rock features. And again, throughout all the different species, they'll have variable summer roosts, which include tree cavities, loose bark, rock features, and human structures. So out of all of these, so 2 of them are currently federally listed. So we have the most recent northern long-eared bat here at the bottom left, and it was recently uplisted from federally threatened to endangered March 31st, 2023. We have the Indiana bat, the top center, which was actually one of the original endangered species listed when the Endangered Species Act was first introduced. And then the bottom right corner is the one that a lot of people have been talking about lately, is the tricolor bat, which is proposed endangered right now. And I believe here within, hopefully sometime soon here, the U.S. Fish and Wildlife is going to be releasing their final determination. Unfortunately, no one really knows that decision yet, but hopefully here within the next couple months, we'll get a final determination. And then the top right, the little brown bat, it's also going to be under discretionary status review here. All right, so how do we survey for bats? So there's different phases of surveys that we can do when we're surveying for bats. And I guess I should take another step back and say why we're surveying for bats. So a lot of these bats, we survey for if a project or some type of habitat or landscape disturbance is going on, because unfortunately a lot of these bats, their numbers have dwindled a lot within the past couple of years, and that's mainly due to white nose syndrome. So white nose syndrome is a fungal disease that affects hibernating bat species within their cave environments. And what it does is, so the fungus itself doesn't necessarily kill them, but when bats are hibernating, the fungus will start to grow on them, and my understanding is it's almost like an itchy, irritating feel to them. So kind of like athlete's foot almost, or like poison ivy. So it's constantly itchy and irritating. And what that fungus is doing is it's prematurely waking them up out of their hibernation cycles. So in turn, what that does is it will prematurely deplete all of their fat reserves before they're able to, before their prey loads are able to come back. And so without the prey loads, they're unable to replenish these fat reserves. So essentially they're either starving because they're not able to replenish this, or if they're out in the middle of winter when all of the natural resources, so like the water streams, lakes are all frozen over there, they also might dehydrate because they're not able to get the water resources that they need either. So because of that, throughout the Northeast, we've seen different states have seen anywhere from 90 to 90% population die-offs for certain bat species, which is pretty significant because they are highly beneficial to the environment. So if a project is going to be built, obviously we don't want to further impact any of we don't want to further impact any more of these bat species. So we want to make sure that we're doing everything we can to avoid any impacts to them. So if a project is being built and in a project screening comes up that, hey, there might be bats in the area, there's various different surveys that we can do. So the initial phase 1 survey is what we call just a potential habitat assessment. And this can be performed year round. And what we're doing is we're going around, depending on the species that we might think would be in the area, we're evaluating not only if there's summer habitat there, so we're looking for different tree types, vegetation composition, landscape composure, but we're also looking for any potentially suitable hibernacula that we might find. So we're looking for mine portals or any types like cracks, crevices that might have the supporting features that would be potentially suitable for the bats. So if we're finding these types of habitats and we think that there is potential for that a bat could exist there, what we might go into next is what we call phase 2 or 3. So that's your presence, probable absence surveys. Now, we only typically perform these types of surveys during the active season when bats are most likely to be in these summer habitats during the landscape. So they will typically comprise of acoustic surveys and or mist netting surveys. So acoustic surveys, basically what they are is we set up ultrasonic microphones. They're taking the echolocation search calls that bats are producing on the landscape, pulling it into like a computer box. And then we're pulling the data back onto our computers in the office, and it's producing a picture of sound. And based off of the frequency, the duration, the shape, we're able to a lot of times tell what species of bats are there. So the benefits of the acoustic surveys is you're able to set up multiple detectors throughout different locations on the landscape, and you without the physical need to have someone there, and you can have them record for months at a time. Now the downside to that is some species, specifically some of the myotis species, they can have really, really similar call features. So it can get to be, I don't say confusing, but if you're looking for, say, the Indiana bat versus the little brown bat, so one is currently federally listed, one is not. So once these species calls start to overlap, it's you don't have definitive proof that the Indiana bat, say you get an Indiana bat call, you don't have definitive proof that it is an Indiana bat. It could possibly be a little brown bat. So that kind of makes it difficult at times. But mist netting, so what we do is we'll go out and set up their basically giant volleyball nets, but a finer mesh. And we'll set it in these flight corridors where we think bats are going to be foraging or flying through. And what bats will do is they'll fly into the net, get tangled, and we'll pull it down, ID it, and take measurements, assess its health, and all that, and take pictures in order to submit to the regulatory agencies to justify our species ID. So mist-net surveys, so the benefits of them is they'll give you like physical proof of the bat species once it's ID'd. Now the downside to it is you're not able to cover as much area as what you can during the acoustic surveys. And so if another thing I should mention about mist-net surveys too, once you start, if you trap a site so often, they'll almost start to get like aware of where the trap is, the mist-net is. So there are times that they could avoid it too, versus the acoustic, there's going to be no physical barrier that they're trying to avoid. Now I mentioned bats echolocate in order to avoid avoid running into objects. So bats can, when they're echolocating, they will be able to perceive a mist net, but a lot of times they perceive it as like what a cobweb is. So when we're throwing up our mist nets, we try and almost create like a funnel corridor. So we put our mist nets up against dense stands of trees on both sides, and then dense overhang branches, so that the path of least resistance is through the mist net. Now, when they're perceiving this throughout their echolocation, yes, like I said, they're still gonna see it, but they're thinking, hey, it's the path of least resistance, so they will try and go through it. Now, it doesn't hurt them or anything like that. It's just like, running down your hallway and you get entangled in a blanket or something that someone threw there. So it's a shock. You're gonna get tangled, you're gonna get mad, but you're not gonna get hurt. And then, so during the fall, if we do find any potentially suitable hibernacula, we can also survey to see if anything's going in and out of these caves. So we do that not only to see, like the health of maybe see the health of a population, but also to see if it's a new portal or mine hole that wasn't previously identified, if bats are using it and to what extent. So if they are using it and it's a good sized colony and or it's a species that we're concerned about, what we would do then is we would put some type of gate or some type of protection around it so that we're able to kind of preserve that environment so that the bats are able to keep using it. And then so radio tracking emergence phase 4, this is kind of a supplement to the mist netting surveys. So if we do catch a rare, threatened, or endangered bat, typically we would like to know where it's roosting. So we would throw a small transmitter on the back of the bat and track it back to its diurnal roost. That way we can perform an emergence survey to see if it's a singly roosting bat or possibly if it's a maternity colony, which is more ideal. Because if it's a maternity colony, that means there's young and potential for population growth. So that would be another situation where there would be protections put in and around that roost. So this is just further information regarding the phase 1 habitat assessments. So typically we're performing habitat assessments for Indiana bat, northern long-eared bat, tricolor bat, or any state listed species. And when you're out performing these potentially summer habitat surveys, you can assess for more than one species at once. In the same situation with a potentially suitable hibernacula, habitat assessments should include any or all services with openings that would be directly or indirectly impacted by a project. So typically for summer habitat, like, we're looking for forest woodlots that have potential roosts, riparian corridors with live dead leaf clusters. So we're integrating all the species preferred habitat characteristics into our assessment and looking for that. Sometimes it might only be suitable for one bat. Sometimes that might be suitable for multiple bat. And so with potentially suitable hibernacula, we're looking for sinkholes, fissures, other karst features that have a physical passageway, airflow, and meet certain temperature requirements that are ideal for their winter hibernation cycles. Typically for the hibernacula at the mouth too, we're looking for lack of obstruction so that they're able to have a clear flight pathway in and out of it, out of the the hibernacula site. Too far. So with the phase 2, phase 3 probable absence surveys, depending on the size of the project and or the area, that determines your level of effort. So mist netting typically requires a lesser level of effort than acoustics does. And that's just typically because, like I mentioned a few slides back, mist netting has a lower probability of detection than acoustics does, and you can't physically confirm the acoustics versus the mist netting. And so the pictures here to the right are just some rough pictures of what the mist net looks like. So this is a closed mist net. You can stack mist nets anywhere from 1 net high to 4 nets high. So that would be anywhere from about 8 feet high to 30-foot high. And the widths of them go anywhere from 2.5 meters all the way out to 20 meters, I believe. So it's in how you select that depends on the type of environment that you're trapping. So if you're trying to trap on a forested road, you're going to select a smaller net that kind of encapsulates just the forested road. However, if you're sampling over a big emergent wetland, typically you're going to want the larger, higher nets. That way, you're able to catch anything that's kind of not paying attention as it's coming through. And then, so the other pictures are just examples of different acoustic setups that we have. You typically try and elevate them off the ground and away from clutter, because if there's clutter in and around that, it'll kind of skew your sound readouts that you have, and it might not give you a clear call sequence back. So if there's not a clear call sequence, you're not going to be as able to as accurately identify the bat species. In that middle bottom picture too, that's kind of just a representative of what the pictures look like of the bat calls. So like I said, it takes echolocation calls, it pulls it down into the storage system. We put it into the computer through an analysis program, and then it produces this picture that enables us to tell what types of species it is. And based off the length, the frequency, the intensity, the shape, we're moderately able to tell what type of species it is. And this is an example of the fall portal trap harp trap surveys. So basically, we'll find a mine portal that's either gated or a new one, and we'll throw a bunch of plastic around it in order to funnel them into what we call a harp trap. And a harp trap is basically a big rectangular frame with a basket underneath it, and within that rectangular frame there's like microfilament lines. So basically it's like fishing line, and they're slightly offset from each other. There's 2 stages that are slightly offset. So when a bat's either flying in or out, it will perceive the first one but not the second one. So it'll avoid the second one, straighten back out, hit it, and then drop into the basket. Similarly with the mist netting, the harp trapping doesn't hurt them. They just kind of hang out in the bottom of the basket until we're able to scoop them out with our hands. And so that from there, we'll sex it, we'll ID the species. We'll take all our different metromorphic measurements, take a bunch of pictures, and we'll let it go. Sometimes they will fly back into the traps, sometimes they won't. And so especially during the peaks of the swarm period, if we think that they're constantly flying in and out, sometimes there are different markings that you can put like on them. I know some people like painting their toenails with nail polish as a mark recapture option, which it's actually kind of neat to see. If you see one with pink toenails, it's it's like, oh, someone caught her before. And like I mentioned, the radio tracking. So this is a little brown bat that we tracked. And all it is a little transmitter that's maybe about the size of a couple pieces of rice, depending on which transmitter you get, and it has the long antenna on the back of it. Um, and and it will, depending on what area of the country or what state you're in, some states have required frequencies. So that frequency will then be picked up by this receiver, and we're able to track it back to the different roost trees of the bats. So I believe this one, the far right with the receiver in it, that was a tricolored bat tree that we were able to find, and then the bottom left, that was an Indiana bat tree. So sometimes you can find them, sometimes they disappear. Most transmitters typically only last about 2 weeks, have a 2-week battery life. So after that 2 weeks, they typically shut off. And the transmitters themselves are attached to the bat with just surgical glue. So again, it's unharmed. It's not harmful to the bat. And typically within that 2-week period too, by the time it shuts off, the bat has groomed it off. So they're just, like I mentioned in the beginning of the presentation, bats are just like you and I, they're mammals. So their hair follicles are constantly growing, their skin follicles are growing. So eventually it'll stop being as tight to the skin, and the bats are able to groom it off. So it doesn't stay on them permanently. And here's some just some pictures of these survey efforts that I was talking about. So on the left-hand side, that's multiple setups of mist nets. And as you can see, like I was talking, you try and create that blockage of the foraging corridor. So both the poles on both net sets are right up against that dense forested area, and they extend upwards up into the tree canopy layer. So we're almost trying to funnel them down into the nets, into the path of least resistance. The bottom left photo is just a bat that's caught in a mist net. Like I said, it doesn't hurt them. He's just really, really tangled up. And sometimes they're really easy to get out. Sometimes it's a little bit more challenging. And sometimes they will actually chew their way through the net too. So like I said, they're not there permanently. It doesn't hurt them. So we're just catching them long enough to determine what types of species are in the area. Again, with an acoustic server, the top right, it's just an ultrasonic microphone where we will put in different habitats throughout the area where you think bats might be. It can be over wetlands, it can be over streams, foraging areas. And then the far right photo, again, is just a slightly more zoomed in photo of the harp trap that we have set up. So we have the plastic funneling them into the harp trap so that we're more likely to catch the bat species coming in and out of those portals. And then finally, something that's relatively new, the bottom center picture is inspecting bridges and culverts, so like different transportation structures for bat occupancy. So like I mentioned, it's relatively new as of the past couple years, where if there's any type of maintenance work going on in any types of these structures, some states are requiring that we survey for any type of bat occupation. And that's because specifically with the tricolored bat being potentially federally listed, they are one of the species that are more likely to roost on these types of bridges. So we want to make sure that we're not impacting these species anymore than we typically would. And yeah, just additional pictures zoomed in of all these little clusters in the caves. So we can go, certain states, we can go into caves and assess the populations of the bats hibernating. Sometimes it's easy when there's only 10 clustered together, but some of these larger colonies, when they're congregating together at 100, 200 bats per cluster, sometimes it's easier as an estimation. And then, just to zoomed up photo again in the bottom center of the little brown bat with the transmitter, you can kind of see the transmitter is glued there and the long antenna. And so before we do put these transmitters on this bat, on the bats, we do always ensure that the transmitter is not more than 15% of the bat's total weight, and that's just so that we're not impeding the flight capabilities of the bat in any way. So this is what I was talking about with bat bridge surveys that are more recently becoming more of a new survey. So basically, there's 3 steps in it. One, just making sure that the structure that you're surveying is safe, and seeing if it does have general suitability for bat occupation. And so that would include considerations for either summer or winter roosting. Depending on the state, they'll look for one or the other. Some states look for both. There's typically minimal dimensions that they look for, and they're pretty minimal. So for most of the bat species of concern, we're looking at anything in exceedance of 3 foot in diameter, and anything longer than 23 foot. So that's most structures that we have on a lot of our transportation corridors. And then we're also looking for cave-like environments if we're looking for winter roosting considerations or stable conditions that keep them out of rain, heavy light or noise pollution within these bridges. And so then step 2 of that process would be just submitting the study form to the state agency or U.S. Fish and Wildlife Office, and then going out and physically doing these surveys. And sometimes, depending on the bridge or structure type, it depends on what kind of like survey methods that you'll use. Sometimes you can go in there with binoculars and and flashlights and look in the cracks and crevices to see if bats are occupying it or not. And now for some of the larger bridges, what we will do is we'll take a GoPro with a diving floodlight and articulated arm and put it on a painter pole to reach 20, 30 foot up in the air. And we're inspecting all these cracks and crevices with a painter pole. Now, sometimes if it's over a big, large commerce way, river or something like that, or it's inaccessible for some reason, you might have to, in lieu of these photo surveys, you might have to do an emergence survey or sometimes survey in a kayak or boat. So it's really it's really at the surveyor's discretion for how to best survey structure, as long as you're doing a thorough and good job that you can produce a probable absence or probable occupancy of bat species. So just because, like bats prefer, what we would think bats would prefer would be like these ideal woodland habitats. That doesn't mean that they're not going to be in the less ideal locations. So these are just some examples of structures that we have found documented bat presences. So the nice pristine mountain stream stone oak culvert here to the left, yeah, there was actually one Myotis species found in it. So that's one example of, kind of like ideal surrounding habitat. It was surrounded by all this nice unfragmented mature forest. So like it's kind of one of those ideal situations where you'd expect to see something in. Now the right 3, it's something that you wouldn't necessarily expect to see colonies in. So the middle photo here, it actually had 3 different rail lines under it. So it had a high voltage line that was a main line from 2 cities, as well as cargo line and some side spurs, where we had train activity there every 10 minutes. So it was kind of those ones where we didn't expect to see anything, but actually this bridge on the right-hand side of the photo above the pier caps, there was actually a colony of about 5 to 7 big browns that we had observed emerging from it. And this is one of those examples that I was saying in the last slide. If you can't get in there safely with the equipment, you kind of have to use supplementary survey methods. And this is where, with all the high voltage lines that are going through here, we determined that it wasn't safe to go in and survey physically. So we had people posted up on each corner of the bridge to observe bats coming out of the bridge. And then this middle right photo here, we also found a huge colony of big browns. And so what we typically do when we're surveying, we'll take decibel readings, temperature readings, and stuff. And the decibel readings for this specific location, it was over a major highway corridor, and it had constant. The average decibel reading was like 93.2 with a max decibel reading of 101.1. So pretty significant noise levels. One of those areas that when you're starting to survey, you're thinking, oh, there's not going to be anything here, but definitely surprised us with their presence. And then the far right photo, it's just the other side of the bridge of the center photos. You can see the multiple rail lines, the high voltage lines. So again, somewhere where you think that there might not be there, but in fact that they were. So
Can
again
I
with
chime
these,
in real quick, Garrett?
yeah,
We are running a little over time, so
okay,
we may want to try to get to questions relatively soon.
all right, yeah, yeah, I can just do this one, then I can hop ahead. Is that good?
Yeah, that's fine.
Okay. All right, cool. So when we're looking for these bridges for occupation, we're looking at the expansion joints, pier caps, anywhere where we think guano or urine remnants are going to be, or actual physical bats are going to be. So any, like I mentioned, any cracks or crevices. So the two right photos, they show indications of remnant and active bat usage. So you can see here on the I-beams and on the column caps, there's remnant guano here. And actually, the far photo to the right is above this column cap, and all this white staining that you can see to the right and to the left of the gap is actually remnants of urine. So it's the uric acid, the salts that are remaining after it dissolves. And if you look really closely into that crack too, there is actually a colony of big brown bats that you can see. And that's just zoom photos of the guano and those big brown bats. And the red circled areas is just remnant bodily grease stains that they're going to be leaving just in and out of certain areas. So their body grease is going to stain. So that's just another indication that bats are constantly using it. So how we can help bats, especially in areas that we think that bats are present, but there might not be ideal conditions. We can create roosting conditions, such as putting bat boxes in, creating like girdling trees in certain areas where it's safe to do. That way, after a few years, it kind of promotes the ideal roost conditions that some of these bat species um, that some of these bat species use. As mentioned before, we could put gates in and around um, mine portals so that we're able to keep humans from disturbing them during their hibernation cycles. Because not only is white nose a concern during hibernation, but also human disturbance, because that will prematurely wake them up and prematurely deplete their fat reserves. As well as just different scientific methods that help to kind of reduce the severity of white nose syndrome, which bats are being plagued with right now. So there's different methods that different states are using in order to help them kind of develop an immunity and give them a fighting chance for the future generations of bats, so that we don't continuously have die-offs or continued population drops. And I will say too, also with helping bats, definitely the biggest thing is, like education. So like I always tell everyone, the first step to conservation is education, just making sure people understand how beneficial bats are to the environment, just interacting with people so that they don't think that they're scary, so that they understand how important they are. So that's definitely the first step in helping bats. That it's so easy for, anyone to do, just, like attend a bat talk, read some literature, um, anything that helps promote a positive understanding and impact on the bat species. Was that fast enough, Matt?
That was great. Thank you. All right. Awesome job, Garrett. Thank you so much. We'll open it up to questions if anybody has one, but I can get us started. Um, a common pro I often hear associated with bats that I've read mixed opinions on is their use, or the fact that some people will consider them to be good mosquito control, which makes sense at first, but also feels counterintuitive since mosquitoes are primarily active in the daytime. Do you have any thoughts on whether or not they actually serve to reduce mosquito populations in any major way?
Yeah, so actually, we just got done publishing a paper on dietary component analysis of big browns and little browns. And so that we found, like while they were eating, I think the composition was like 30% mosquitoes, a lot of their diet was also like the moths and the and different beetle species. Now, if you remember, I said, like bats aren't entirely active throughout the night, and they're most mainly active at dusk and at dawn. So that's typically, you'll still see a surgence of mosquitoes in and around, especially the dusk time. Um, so, but um, but yeah, like our analyses did show that they were eating a large amount of mosquitoes. But that too, it's also going to be dependent on the prey availability in the area. If there's going to be more mosquitoes in the area, they're going to be eating more mosquitoes. If there's more beetles, they're going to be eating more beetles. So, yeah.
Interesting. Thank you.
Garrett, I had a question. Really interesting talk, especially on how they're surveyed and all the work that we do to do conservation for them. I have two short questions. One is I don't know the how the virus is generated, like what causes the virus that they're getting this white nose syndrome to begin with. And then my other question was, do they have any predators within the food chain?
Yeah. So, yeah. So white nose syndrome, it came to New York. They're thinking from Europe in 2008. And what white nose syndrome is it's a fungal pathogen, right? So, and unfortunately with fungal pathogens, if someone's in this area and keeps it on their boots or clothes and they start taking it to other caves, it's going to spread and manipulate and evolve there. So not only can it attach to humans, but it'll also attach to bats. So so sometimes bats within the wintertime, they're switching in between hibernaculum sites. And unfortunately, this fungus, its optimal growing conditions are the same ideal conditions in which bats hibernate in. So it's kind of, um, it's, it's unfortunate that they closely overlay that much. So unfortunately, it's extremely hard to get rid of the fungus after it is starts growing within a cave, other than completely neutralizing everything in it. So that's why I can speak like Pennsylvania Game Commission. They've been employing methods that it's almost they're spraying the caves with this non-toxic film, and what it does is it desiccates the fungus long enough and inhibits growth so that by the time the bats really start to get infected with it, they're coming out of their hibernation cycle. So it gives them a fighting chance, especially the ones that have the larger fat reserves, to come out of the hibernation without, starving to death, anything like that. But then it also kind of helps them simultaneously kind of develop an immunity or a resistance, I guess, a resistance to the fungus throughout the year. So it's not going to be something that it's going to take a while for these bat populations to rebound, and it's not going to be anything, white nose syndrome, that's ever going to go away, unfortunately. But hopefully, throughout the generations, they're able to develop that tolerance to it. So yeah.
Thank you.
But yeah, but the bats, unfortunately, because they congregate, because they're social congregators, they're infecting each other, and as they're going different places, it just keeps spreading, and that's why. So it started in New York, and it's progressing westward, unfortunately. What was the second part of that? I think
Oh, if
wasn't there
they have any natural predators in the food chain?
Yeah. So obviously they're active at night. So like owls, any nighttime birds of prey that are out there. I don't think I have it in this presentation, but I actually have a snake, eastern black rat snake, hiding out at a bat gate that caught a bat as it was coming out. The skunks, feral cats, and house cats, and then also raccoons, will also prey on them. And I believe one state agency has a trail cam photo that they have set up on a hibernation site where they actually saw there was a bat that was roosting low enough to the ground, and they showed a video of a raccoon coming in and actually like plucking it off the wall and eating it.
Wow. Did not know that. Thanks.
Any other questions? What's your favorite bat, Garrett?
Eastern small-footed. Don't know why. Don't have a reason.
All right. Well, I guess we will wrap it up then. Thank you everybody for attending. Garrett, that was a great talk, very informative. I really like bats. I'm a big proponent of spreading the word on why they're really important and the different ways we can do to help conserve them and try to boost their numbers. So we really appreciate you taking the time to speak to everybody today. We'll be sure to recommend this video for anybody that shows some interest in increasing their bat knowledge. And with that, yeah, we'll call it. So thank you all again. This was a great talk, and we hope everybody learned something today.